Hi everyone, welcome back to my Numbers Dance series. Today we're going to be talking about fractions. This is going to be the first video in a little mini series about fractions. Today we're going to be doing specifically comparing fractions. So comparing fractions is one of the really basic things that you should know how to do with fractions, but it's also one of the most common things that they're going to test. I think, pretty much a one on every test, you could say. So I'm going to assume that everyone watching this kind of knows what a fraction is and is familiar with the very, very basics about fractions. So we can move on to, how do we compare fractions? Well, I'm assuming that we know how to convert fractions into different denominators. That is, if I give you a fraction, for example, 5 over 9, and I multiply the numerator and the denominator by something like 2, so I would get like 10 over 18, these are the same fraction. If you multiply the numerator and the denominator of a fraction by a number, the same number, then it's the same fraction. And similarly, if you divide them by the same number, they're going to be the same fraction still, right? So this is how we're going to basically compare fractions, because we know that we can't really compare fractions if they have different denominators, right? This is 5 over 9 and this is 6 over 11. Well, 9 and 11 are very different numbers, right? If we have, maybe you're thinking about the pizza diagram, you can't really compare 1/9 and 1/11 super properly. So we have to make them into the same denominator in order to be able to compare them. How do we do that? Well, we can multiply this by some number and we can multiply this by some number, and we want, in the end, those two numbers to be the same. So what we can do is we can multiply this 9 by 11 and we can multiply this 11 by 9. And in the end, they'll both be 99, and then we can compare them. So let's do that. If we multiply the top and bottom of this by 11, what we're going to get is 55 over 99. If we multiply the top and bottom of this by 9, what we're going to get is 54 over 99. And now we see that actually 55 over 99 is greater, so 5 over 9 is greater. But this is kind of a, long process, right? We have to multiply this and this, we have to multiply this and this, and then we have to compare them. There is a way to do it, slightly easier. It's going to be the same process, but it kind of like skips a step in your head. And it's called the butterfly method. What the butterfly method does is you just multiply these two numbers and you just multiply these two numbers and then you compare them. And if you think about it, we're actually doing the same thing here, right? We're still multiplying 5 by 11 to get 55, and we're still multiplying 6 by 9 in order to get 54. The thing here is that we're just looking at the numerators, essentially. We're skipping the denominators because we know they're the same. So we're just doing the process of getting the numerators and comparing them. So the butterfly method, so named because these two things kind of look like a butterfly wings, what we do is 5 times 11, that's 55 on top, remember. That's 9 times 6 is 54 on top. 55 is bigger than 54, so we choose this. And remember, notice, it's like really the same thing. We're just skipping, we're having to write all this stuff. So let's test this out on another problem. 4 over 7 versus 5 over 9. Again, we could do the entire process of, transforming this into a denominator 63, this into denominator 63, but we can kind of skip a little bit of that. Still the same process, but skip, writing some numbers down, and just do this. What's 4 times 9? It's 36. What's 5 times 7? It's 35. And so which one is bigger? 36 is bigger than 35, so 4 over 7 is bigger. Very nice. Now, on to 3 over 7 versus 3 over 5. Now, you can use the butterfly method here again, right? You can say 3 times 5 is 15, 3 times 7 is 21, so 3 over 5 is bigger. But also, let's notice something. 3 over 7 and 3 over 5. The numerators are the same. So if the numerators are the same, that means the only difference in these two fractions is in their denominators. So now we can kind of ask ourselves, okay, does a denominator of 5 make something bigger, or does a denominator of 7 make something bigger? And, if you don't know the answer to this intuitively, that's all right. If you do, that's wonderful. But if you don't, I can just explain it really quick. Imagine you have, a pizza and you're dividing it between 5 total people. Or you have a pizza and you're dividing it between 7 total people. In which scenario are you going to get the bigger slice? Of course, if you're dividing it between less people, you're going to get more pizza per person. So 3 over 5 is going to be bigger. The smaller the denominator is, the bigger the fraction is. So we can, even without multiplying, if we notice that the numerators are both 3, we can just look for the smaller denominator. And either way, we're going to get 3 over 5. Now our next question, 2 over 23 versus 3 over 34. Now, once again, this is going to be kind of a similar question to these two up here, because we can look at this, 2, 23, 3, 34. None of these numbers are the same. We can't really do too much to compare them. So we will default to the butterfly method. Butterfly method, cross multiply. 2, 34, what does that make? 68. 3, 23, what does that make? 69. Nice. And which one's bigger, 68 or 69? It's going to be, of course, 69. So we can say 3 over 34 is bigger. And notice that we really do have to use like cross multiplication or something here. If you wanted to convert this into decimals, you would see that the difference is so small that you would probably run out of time or make an error before you even got the answer. So really stick with fractions here. Now finally, we have another interesting example. 6 over 7 versus 7 over 8. Now, of course, if you see this, you can always just use cross multiplication, or the butterfly method. Cross multiply, 48 and 49, 7 over 8 is bigger. All right. But this question is interesting for other reasons, and I think really understanding this question can help you with other things. So let's not think about this cross multiplication for now. Instead, there are kind of two other ways we can look at this question. One of them is, instead of thinking about it as 6 over 7, we can think about it as 1 minus 1 over 7. Instead of thinking about it as 7 over 8, we can think about this as 1 minus 1 over 8. And so if we're trying to compare something like 1 minus 1 over 7 and 1 minus 1 over 8, we think, which one is bigger? Well, in order for a number to be bigger, we should be subtracting a smaller number, right? So then we look for, okay, is 1 over 7 smaller, or is 1 over 8 smaller? And of course, we can figure out from this logic that 1 over 8 is smaller, so we can say 7 over 8 is bigger. But I will admit that is a bit of a lengthy process, so it's not necessarily super applicable for this problem, but definitely like knowing this idea can be super helpful. Now, another way of thinking about this, and this is another one that's going to be, I think more applicable, is noticing that 6 over 7 and 7 over 8. In order to get from 6 to 7, we add 1. To get from 7 to 8, we also add 1. Now, maybe you remember if you were trying to add fractions and your teacher asked you what's 1 over 2 plus 2 over 3, and you said it's 3 over 5 because you said 1 plus 2 equals 3 and 2 plus 3 equals 5. Your teacher told you that is wrong, and that is wrong. But we can use an idea that is a little bit similar to that here. We notice that we're adding 1 to both of these. So how can we think about this? Well, here's the analogy that I like to use. Imagine that you have a jar of lemonade, right? Your jar of lemonade has some amount of lemons in it. We're not going to worry about the lemons. We're going to worry about how sweet your lemonade is, right? Imagine that you have 6 pounds of sugar. 6 pounds, right? Wow, holy diabetes. 6 pounds sugar and 1 pound water. I don't know if that's physically possible. It's probably not, but let's pretend. 6 pounds of sugar and 1 pound of water. Okay, now imagine in this lemonade, you have 7 pounds of sugar and 1 pound of water. Now, how do we determine the sweetness of lemonade? Well, it should be pretty obvious that the sweetness of a lemonade is basically how much sugar is in it. But not only that, how much sugar is there compared to the water? In other words, it's a fraction, right? The fraction of sugar to total volume, or sugar over sugar plus water. Here, that would be 6 over 7. Here, that would be 7 over 8, right? 6 sugars over 7 total, 7 sugars over 8 total. So now we ask, which lemonade is sweeter? Well, of course, this lemonade has 1 more pound of sugar than the other one. It's like you took this lemonade and just added more sugar. If you add more sugar to a lemonade, of course it's going to be sweeter. So we can kind of rationalize that this 7 over 8 is going to be bigger. And this idea just does not only apply in this problem, it applies when we add any number. For example, 6 over 7, what if I added like 8 to the top and bottom? 14 over 15. This idea still applies. It's only like we're adding, 8 pounds of sugar this time. And of course, if you add 8 pounds of sugar, it's still going to be sweeter. 14 over 15 is going to be bigger. In fact, we can generalize this. if we take a fraction, any fraction, a over b, and then add some number c to both the top and the bottom, provided that this original fraction is less than 1, then this fraction is always going to be bigger than this fraction. Because remember, we're just adding more and more lemonade. We are making the lemonade sweeter and sweeter. So that is kind of how this problem works. So hopefully you guys learned something about comparing fractions, even if you already knew the butterfly method. But if you didn't know the butterfly method, absolutely remember this. Cross multiplication, the most important thing in this video. If you already knew that, feel free to think about, maybe this thing in your free time, or especially this thing, which I find kind of fascinating. So that's going to be it for today. Thank you guys for watching, and I'll see you next time.